Hello everyone, my name is Arash Joorabchi. I'm a lecturer in the Department of Electronics here at UL. This is a short introduction to the professional diploma in natural language processing. So first of all, what is natural language processing? In natural language processing, we look at different ways, ideas, methods, and techniques to make computers understand humans' natural language. And what we think of natural really is not that natural to computers, because human language is a very complex phenomena, and therefore we have to come up with very smart techniques for the computers to be able to understand and comprehend this phenomena. So we have all heard the expression, the picture is worth 1,000 words. Now, if you look at this statement in more details, the bandwidth between the human eye and the brain is about 8 million bits per second. So if you want to convert that to number of words per second, that would be about 800,000 words per second. In the terms of a spoken word, we are looking at around 2 words per second. So we are looking at a bandwidth which is only 2 words per second, whereas in terms of the communication between the human eye and the brain, we are looking at 8 million bits per second. So it's a huge bottleneck in terms of data communication when we look at the topic of human language. So from another perspective, if you look at the difference between the vision and human language, in the vision systems, we have a parallel data transmission. You have all these lights and colors coming into your eye and transmitted to your brain in parallel. And what you see is what you get. There is very little compression, if you like. But in the language, because of this serial data transmission format, where you have only one word coming out at a time, then there has to be a lot of complexity to be able to kind of compress the data and transfer it in an effective way. So, for example, each word can take on many different meanings. The word NLP, for example, can refer to neuro-linguistic programming, could refer to natural language processing, or it can even refer to the National Library of Poland. So we have a lot of information embedded into the word, and then the meaning of the word can be defined by its context. So we have this famous saying in NLP which says, you shall know a word by the company that it keeps, meaning that the words are getting their meaning from their context. This problem is known as the problem of word sense ambiguity, and the systems that try to address this issue are called the word sense disambiguation systems, and that's a major topic in natural language processing. Now, in terms of the scopes and domains, you can think of NLP as a subdomain of artificial intelligence, which borrows a lot of techniques and methods from machine learning and deep learning. So if you're looking at the field of NLP and its tasks and subdomains, you can think of examples such as text classification or categorization, in which you have a number of different categories or classes that you want to classify your documents according to. Or you can think of the problem of machine translation, where you want to convert your text from a source language to a target language. Or another example would be the case of named entity recognition, in which you want to identify named entities in a piece of text. So these named entities could be the name of a company, the name of a person, the name of a location. These are known as named entities, and the goal of this task is to identify those named entities in documents. And then we also have this kind of subfield in NLP called the natural language understanding. Now, the goal of the natural language understanding is mainly comprehension. So examples of tasks in NLU include sentiment analysis. In sentiment analysis, we have a piece of text for which we want to come up with a sentiment. Is it a positive review, for example, for the movie? Is it a negative one or a neutral one? The other topic in NLU is question answering. You have given a question and you have a large database of answers or a knowledge base of answers, and you want to find or match the perfect answer for that question. Another topic which is quite popular is dialogue agents and chatbots, whereby you want to create a system which is able to hold a simple conversation with humans and answer their questions. Now, in terms of the general topics in NLP, we can look at two different eras or main categories. One is classic NLP and the other one is deep learning NLP. In classic NLP, we do a lot of pre-processing and also something called feature extraction and feature engineering mainly. So in terms of feature engineering, you can think of if you have the case of, for example, identifying key phrases or keywords in the document, what type of features can we think of in terms of a word being prominent in that piece of text? One thing would be the frequency of that word, how many times that word appears in that document. But you also have these other features. For example, does the word appear in the title? Does it appear in the abstract? Does it appear in the references? These are all the features that you can think of. And then the features would be dependent on the task that you are trying to address. So for each task, you would engineer your own set of features and you try to optimize those and therefore optimize your model. But then when it comes to the deep learning approaches, you basically leave the task of feature engineering to your machine learning model. And these models are mostly deep neural networks that you use in this context. Now, in this program, we take you through a journey in the NLP landscape, and this program is delivered in 2 semesters. You have 2 core modules per semester. The very first module that you have is Introduction to Natural Language Processing. In this module, you learn some very basic concepts of NLP. For example, how do we use regular expressions to identify patterns in a piece of text? Or how do we use stemming or lemmatization to get the root of a word? Then you learn some algorithms like the Levenstein algorithm, which looks at the distance or difference between 2 pieces of text. You also learn about language models, some simple language models that try to identify the probability of a word given another word. So, for example, if you have the word computer, how likely is it that the next word is programming? And so on. You also look at the topic of spell checking. Another important topic covered in this module is the text classification using the naive Bayes algorithm. And you finally look at the evaluation methods used for these classification systems. These include the precision, recall, and their harmonic mean F1. The second module in the program in the first semester is the information retrieval, which looks at the topic of free text search. If you have a large collection of documents, what kind of methods and systems you use to be able to effectively and efficiently search these documents. We look at open source tools for this, such as the Apache Lucene. We look at the underlying methods and systems like the inverted index, the vector space model, in which you look at the distance between into the text documents in terms of their Euclidean distance or cosine similarity. We look at the weighting mechanisms for the words, such as the term frequency, inverse document frequency. And finally, in this module, you look at the semantic web technologies, such as the XML, Sparkle, and RDF. In the second semester, we look at the topics concerned with deep learning approaches to NLP. These include topics such as word embeddings, which looks at creating condensed vectors for representing words in a document or documents themselves. We also look at popular neural network architectures for NLP. These include the RNNs, the LSTMs, and the GRUs. And finally, we look at the state-of-the-art architectures for neural networks in the NLP, which are called transformers. In the second module of the second semester, we look at the topic of natural language understanding. Again, most of this module would be based on deep learning methods. So the task that you would consider here would be sentiment analysis, name entity recognition, and also part of speech tagging. All of these would be using deep learning approaches. And the second half of the module would be mostly concerned about 2 main topics. One would be question answering. given a question, how do we find the answer to that question in a large knowledge base or a database? And also we look at the development of simple chatbots using the current technologies which are available. Thank you for your attention. If you have any questions about the professional diploma in NLP, please contact me or any member of the UL at Work team.